Today, we're going to follow the incredible journey of a single click. We're going to pull back the curtain on the hidden system. Think of it like a digital postal service that makes our entire connected world tick. So, let's dive in.
Really think about that for a second. You hit send on a message and poof. In what feels like a blink of an eye, it shows up on a screen thousands of miles away. How on earth does that happen? It seriously feels like magic, right?
Well, you guessed it, it's not magic. It's actually one of the most organized, highly structured journeys you can imagine. And it's all governed by this universal set of rules that pretty much every device on the planet has agreed to follow. And today, we're going to map that entire journey out.
Okay, first things first. Before any data can go anywhere, devices have to have a physical way to connect to each other. This is the bedrock, the absolute foundation of everything else we're going to talk about. So at the most basic level, you've really got two kinds of networks. First, there's the one in your house, right? The one that connects your laptop, your phone, your TV. That's a local area network, or LAN. But then you have these massive networks that connect all those little LANs together, across cities, countries, even oceans. Those are wide area networks, or WANs. And the internet? Well, that's the ultimate WAN. Now, how all those devices are actually arranged isn't just random. It's not a big jumble of wires and signals. It follows a very specific layout, a kind of map. And that map is called a network topology. It defines exactly how information is supposed to flow between every single point. And chances are you have this exact map in your home right now. It's called a star topology, and it's super popular because it's simple and really reliable. Your Wi-Fi router, that's the central hub. And all your devices, your laptop, your phone, your console, they're all spokes. If your laptop loses its connection, it doesn't matter to your phone because everything talks independently through that one central point. So we've got the connections and we've got the map. But just like our roads need traffic laws to prevent total chaos, our networks need rules. Without them, it would be an absolute mess. These rules are the protocols and standards. You can think of a protocol as a shared language. It's a really strict set of rules that devices agree on before they even start talking. It's what makes sure that a message sent from, say, an iPhone on Wi-Fi can be perfectly understood by a Windows PC plugged into an Ethernet cable. This is what makes universal communication possible. Without protocols, the internet would just be digital noise. Okay, but with so many different devices and all these different tasks, sending an email, streaming a movie, how do you even begin to organize all of those rules? Well, you use a layered system. And the most famous, most foundational one is called the OSI model. To really get our heads around this, let's use an analogy from our source material that just makes it all click. Imagine trying to send a letter, but there's no post office, no mail carriers, no sorting centers, nothing. You'd have to figure out every single step yourself. It would be an absolute nightmare. See, the Postal Service is genius because it solves this by breaking the whole process down into layers of responsibility. Your job is just to write the letter and address the envelope. The mail carrier handles the local pickup. The sorting facility deals with the logistics. Each part does its own specific job and trusts that all the other parts are doing theirs. And that is exactly how computer networks manage the unbelievable complexity of sending data around the globe. They use a layered system where each layer has one very specific job to do. And that system? That's the OSI model. So picture this. It's the late 1970s, and all these different computer networks can't really talk to each other. It was a mess. So the International Standards Organization stepped in and created a universal blueprint to fix the problem, the OSI model. It's a 7-layer framework that standardizes communication. It's basically the official rulebook for our digital postal service. All right, so let's actually follow a piece of data on its journey through these 7 layers. We're going to see how a simple click gets prepared, packaged up, sent out on the road, and then perfectly reassembled on the other side. You know, the easiest way to think about this is to group the 7 layers by their main job. So, up at the top, you've got the application layers. This is the stuff you interact with, your web browser, your Zoom call. Its job is to prepare the data. Then, the delivery layers in the middle act like the logistics department. They break your data into little packets and address them for the journey. And finally, you have the hardware layers at the very bottom. This is the physical stuff, turning your data into electrical signals for a cable or radio waves for Wi-Fi.
And here is the absolute key, the real magic of the whole system. When you send a message, your data travels down all 7 layers on your device, getting packaged and wrapped up at each step. Then, after it crosses the network, it travels back up all 7 layers on the other person's device, getting unwrapped step by step until it appears perfectly on their screen. It's a perfect mirror image. So, why does any of this deep in the weeds technical stuff actually matter? Well, because this completely invisible underlying structure is what makes our entire modern connected world even possible. It all comes down to this number, 7. This elegant 7-layer architecture is the true unsung hero behind pretty much everything you do online. Think about it. Secure online banking, flawless video calls, accessing your files from anywhere. Every single one of these relies on this model to work reliably. It's the quiet engine of our digital world. And the real genius is that because each layer is independent, engineers can invent, say, faster Wi-Fi without having to rebuild the entire system from scratch. It's what allows the internet to constantly evolve and get better. So, to wrap it all up, all communication needs a physical path, a topology. Protocols are the essential rules of the road that let different devices talk to each other. The 7-layer OSI model brilliantly organizes all those complex rules, and the whole thing just works because each layer focuses on its own specific job, allowing the entire system to function seamlessly. But I want to leave you with one final thought. This framework, this amazing system, was designed in the 1970s for a world that, let's be honest, doesn't really exist anymore. It's been incredibly resilient, but as we build a future packed with AI and billions of smart devices, you really have to wonder, what does the next digital postal service look like? What comes after these 7 layers?